All right, let's get right into it. And I have to laugh when I say this, but bad news for some of you. A ton of this unit, solving for sides, you're going to have to factor. Sorry. It's the way it is. It's a big, huge part of this unit is factoring. Huge part. All right, huge part of this unit is factoring. So I don't know if 3 times is the charm for some of you to get this figured out, but we'll find out. All right, let's get it started. You're going to be setting up a lot of ratios in this unit, a lot of ratios. I'm not even going to go over any triangles today. We're not even going to talk about triangles. All it is can you solve a proportion? Okay. Before you start solving them for me, ratio, 2 numbers. Okay. Ratio is the comparison of 2 numbers. A bunch of different ways I could write it. I could write the word 2 in between. Here's how we're going to see it probably, is with those colons in the middle. All right, A to B. Quick example of how to write a ratio. I got a scale model of a car, 4 inches. The actual car is going to be 15 feet. What's the ratio length of the model to the length of the actual car? Now notice what I have in parentheses. If you're going to write 2 to 3, whoever's reading that is going to assume that's in the same units. It's 2 inches to 3 inches, 2 feet to 3 feet. They're not going to assume one's going to be in inches and one's going to be in feet. So when you do write a ratio down, you have to make sure it is in the same units. All right, so I have a 4-inch long model car and a 15-foot actual car. We got to make a decision. Inches, or feet? All right, inches then. So it's going to be, what is the ratio of the model? What's the length of the model car? 4 inches, so 4, 2. Now I can't put 15 down because I'm assuming that's going to be 15 inches. All right, so I need to convert the 15 feet to inches by multiplying it by 12. And it's going to end up being 180. So the ratio here, 4 to 180. If you do want to reduce that, that's fine. Not needed, though. If you want to say it's 1 to 45 when you reduce it, that's fine, but it's not needed. Okay, but the units need to be in the same. The units do need to be the same when you write a ratio. And it's going to be in the correct order. If I write 180 to 4, that's incorrect. All right, it's asking me specifically, model to the actual car. Model to the actual car. All right, all good there? Not too bad. I don't want to spend too long because I want to get to the factoring today. All right, I put 2 ratios equal to each other. I end up what's called a proportion. All right, if I write, can I write 2 or more ratios in there? Yeah, I just call it an extended proportion like I have right here. All right, if I have 2 or more there, I call it extended. Here's where we're going today. How do you solve these bad boys? I'm sure you've had years and years of experience with it. 2 ratios equal to each other. How do I solve for the variable? Cross multiply, done. Cross multiply. So on this first one, I'm going to go through quick. I cross multiply. I got 5 times n, and I got 2 times 35. 5n equals 70. We're all right on how I got that. I'm going to go quick with you guys here before we get serious. And we end up n equals 14. No issues? Okay, number 2. When you do cross multiply the 2 and the x plus 1, what do you got to do with the 2 here? I do have to distribute it, yes. So I'll just show that real quickly. So I have 2x plus 2 equal to 3x. Move the 2x over, x equals 2. All right, any issues here? Going. Okay, next one, we got to do a little bit more algebra work. Notice this x plus 6, it doesn't look like a ratio, but it is. When I put it over 1. So you're going to have to multiply x plus 6 and x minus 6. I don't know what you called that last year. I'm not a big fan of the term FOIL. I like the word double distribute instead. So I'll give you guys a second to go ahead and distribute the x, and then distribute the positive 6, and then let me know what you get. Please clean it up. Combine all your like terms that you can. We ready to go? All right, here we go. 2, after you did everything, what do we end up with? X squared minus 36 because the 6x and the negative 6x canceled each other out. All right, where do I go from here now? Got to solve for x. Where do I go from here? Go ahead, Orion. Okay, so you want to move the 13 over and get it equal to 0. Okay, anybody else want to do something different? Because that's one way. Paige? I could move the 36 over. All right, I'm going to do it that way just because I really don't want to introduce. If you do it your way, Orion, that's fine. You're going to have to factor. Okay, I'm not prepared right now to show factor and blow people's minds yet. So let's move the 36 over. Yep, you get x squared equals 49. Perfect. And then on both sides, how do I get rid of that squared exponent of a 2? Take the square root of both sides. Now, if you decide to do it this way, that's fine. You got to be careful, though. Because a lot of you are just going to say, hey, x equals 7, I'm good to go. Not the case. Not the case. Okay? Caitlin, what's the problem? Positive or negative 7. Are you guys familiar with this notation, plus or minus? We familiar with this? Okay? So anytime you take the square root of a number, you're left with the positive and negative version of it, remember. Positive and negative version. Bless you. We are right there. Okay, time to put on your big boy, big girl pants. Here we go. Using factoring. Go ahead, cross multiply. X squared minus 2x equals 5x plus 30. All good. Okay, let's go. Here we go. There's no more leaving it blank. No more leaving it blank. If you have a squared term here, squared term, you need to get one side equal to 0. Try to keep the x squared positive, please. I'm not a big fan of dealing with negative x squared, so try to keep it positive. So how am I moving the 5x over? Subtract it over. So when I subtract it over, it becomes minus 7x. How do I move the 30 over? Subtract it. Get one side equal to 0. All right, now I'm going to slow down, and I'm sorry if it's boring. So I'm going to slow down. Okay, here we go. This is the only type of factoring I've been having you responsible for this year. What is the C term up here? There's an A, a B, and a C term. What is the C term? Negative 30. All right, C is negative 30. What is my B value? Negative 7. So you now have to play a game with yourself. Two numbers that multiply to the C. So two numbers that multiply to negative 30, but at the same time will add to your B, negative 7. So that's what I'm going to be looking for someone randomly here in a second. Two numbers that multiply to negative 30, but add to negative 7 at the same time. You guys that struggle with this, my best piece of advice, start with numbers that multiply to 30 and see if you can get a 7 out of them somehow. Numbers that multiply to 30. All right, here we go. Numbers that multiply to 30. Here we go, 25. Got numbers for me?
Negative
10 and 3 work. Put the x's here. If you want to add to negative 7, the 10's got to be negative. The 3's got to be positive. And then there's one more step to solve for x. And I do not need to see this step because I know most of you know what the deal is. But you set each of those equal to 0 and solve. Most of you already know you're just going to take the opposite out. So one of my answers here, x equals 10 and x equals. Is there a diagram involved at all in this problem? Any diagram? No. Why do I mention that? We're keeping both. There's no rejecting the negative here. There's no need to. There's no diagram or anything. They're both answers. Perfectly acceptable. All right. Everyone all right there? All right, next up, number 2. 3 times x plus 5, x plus 1, and x plus 3. Got to do a little double distribute on one side. I'll ask somebody in a second what we end up getting. All right, x plus 1 times x plus 3. What do we end up with? Here you go, 9. What do we end up with? 3x plus 15 equals x squared plus 4x plus 3. Oh boy, are we ready? X squared. What do I get here? And now what do I get here? Well, and then you combine them and you get 4x. And then lastly here, 1 times 3. All good there? Yes? See where we made our mistake? Everyone sees a squared? Okay, time to get one side equal to 0. All right, one side equal to 0. And then here we go. Number 28, you're helping me out here. How do I move the 3x over? Okay, what's it become now here? I got 4x minus 3x. And then how do I move the 15 over? Yep, so 3 minus 15. Yep, minus 12. All right, 2 numbers that multiply to this and add to this. Multiply to your C and add to your B. What's my C value up here, guys? Negative 12. And what's my B value? Nothing showing, but there is a 1 there. So you need 2 numbers that multiply to negative 12 but add to 1. And when you're ready, those numbers, 15, those numbers multiply to negative 12 and add to 1. Positive 4, negative 3. One more step, got to solve for x on each. So x, one answer, x equals negative 4, and x equals 3. Anything, because I am going to walk around and watch you do number 3. Okay, number 3 is no different than what we did with 1 and 2, so I'm going to walk around and see what you got with that one. All right, looks like most of us have this one down pat. X squared plus x equals 20. You move the 20 over by subtracting it. We found two numbers that multiply to negative 20 but are one apart, and that was positive 5 and negative 4. And then we have x equals negative 5 and x equals 4. Just make sure the signs are correct, negative 5 and 4. Any issues there? And then also walking around, I saw most of you taking a dive at number 4. All right. Unfortunately, though, number 4 isn't the same factoring type as this. It's a new fact. Not new, but not one we've done this year or reviewed. All right, so you cross multiplied. Everyone has 3x squared on one side, and on the other side, 30x, right? We're all good there? Still need one side equal to 0. That's not changing. Still need one side equal to 0, and I prefer that 3x squared to stay positive. So how can I move the 30x over? Subtract it over. So here's what I'm looking at right now. 3x squared minus 30x is equal to 0. You can't play the multiply to C, add to B game anymore because there's only how many terms up there? 2. You can only do that game when there's 3 terms and the A value is 1. I don't have that here. So now we need a new method of factoring, right? Which you've done in the past, which is, hey, 3x squared minus 30x. I see a 3 and a 30. Can't you take something out of that? What can I take out of a 3 and a 30? The highest number I could take out would be a 3. Yes, I could take out a 3. And also, they both have what variables in it? X squared and x. You can take out the one with the lowest exponent. So out of the 2, which one has the lowest exponent? Just the x. So you can take out a 3x. This method, the 3x you just took out, is known as Gcf method. No? What they have in common? I know we're going back a while. All right, but that's called the Gcf method. Take out what's in common. Now, hey, hold on. Everybody stop. Going back to this one. Do you see how I cannot do a Gcf here? There's nothing in common other than a 1. You can't take out an x. Why not? The 20 doesn't have 1. All right? And there's, other than a 1, there's no other number they have in common. So that's why I didn't even bother with it in any of the other problems. So I took out a 3x. Got to tell me what's left now. I had 3x squared, and I just took out a 3x. What do I still have left here? An x. Because I had 2 of them, and I took 1 out. Minus 3 into 30, 10. And I already took that x out. It's right here, so there's no variable left. Equal to 0. All right, now what do I set equal to 0? Well, certainly I'm going to set the x minus 10 equal to 0. And get one answer as x equals positive 10. And yes, you are going to set your GCF equal to 0. 3x equals 0. What are you going to do here now to solve for x? How do I get the 3 out of there? Because it's not subtracting it. Divide both sides by 3. One answer is 10. The other answer will be 0. 0 and 10 should be my answers there. Okay, so watch out for that method, GCF. All right, watch out for taking out a GCF. All right, here we go. I got to review some simplifying radicals. I know we've been doing it all year on tests and quizzes, but there's a reason why I need to review it right now. So square root of 72. I believe I did this one last week, huh? Simplifying the square root of 72. Your job, and I may teach this different than last year. If you want to do whatever you learned last year, keep going. I always break a radical down into 2 radicals. Underneath 1 is the biggest perfect square that can go into here, 72. So the biggest. I know 9 does. I get it. I have no idea if 16 does, but if it does, there's something bigger, though. You need the biggest one that goes into 72 evenly. 36. And now underneath the other one is a non-perfect square. So 36 times what gives you 72? 2. And then let's finish this up. Square root of 36, 6. And then the radical 2 comes along for the ride. 6 radical 2. All right, what about the square root of 32 now? First job, biggest perfect square that goes into 32. 32. Biggest perfect square, what is it there, 16? 16 for 16, look at that, yes. And then what do you multiply it by? 2. So this breaks down into 4 radical 2. Oh, now I got a little dividing it. All right, no big deal. Break down the radical first. 48, go ahead, break it down. 48. Find a perfect square that goes into 48, the biggest one preferably. $18, biggest perfect square. 16. And 16 times 3, I believe. All right, so I have 4 radical 3 in the numerator. In the denominator, I have 2. Can I go any further? Or do I leave it like that? Can I go any further? That is not simplified all the way. Because what can I do with the 4 and the 2? Divide them out, and it'll end up being 2 radical 3. All good there. And then next one, square root of 150 divided by 5. Hey, I don't know if anybody was thinking about this. You cannot divide these numbers right now. One's underneath the radical and one's not. That's a no-go. No-go. All right, they both have to be underneath the radical for you to divide them. So need somebody to break down 150 for me. Biggest perfect square that goes in evenly. 150. Did we find that perfect square for 150? 7? 25 is a winner, yep. 25 times 6. Square root of 25 is 5. Square root of 6 over 5. Can I keep going? Can I keep going here? Yep, final answer, square root of 6. Why did I just throw this radical review in the middle of factoring? Because you are going to need to know how to break down a radical when you are asked to use the quadratic formula. Familiar from last year? Okay, first thing is, you never have to memorize this for me. I'll give it to you. All right, it's going to be on the reference sheet you get for the Regents exam, so why not just start giving it to you now? All right, so you do not need to memorize it at all. Okay? Before we use it, though, I do want to introduce a part to you, a part of the quadratic formula, and that's the part underneath the radical called the discriminant. Is that a familiar term from last year? Sometimes, yes, no? Okay, well, anyway, it's the part underneath the radical and quadratic formula, and it's pretty powerful because it will allow you to tell before you even start a problem if you can factor it or not. Okay, so take a look. I have 2x squared minus x minus 15. Maybe I want to try to factor it, but I don't know if I can or not. All right, I don't want to waste my time if it's not factorable. So I'm going to use the discriminant right now to figure out if I could actually go ahead and factor that. I can use the discriminant. I'm going to show you how. Everyone, you told me at the beginning, you know what an A, B, and a C value is, correct? Okay, what's the A value on this trinomial up here? No. It's just a number. There's no variables. 2. The B value. Sign goes with it. -1, and your C value. -15. All right. Now we're going to plug in for B, A, and C. But hey, you're not going to do it yourself. Everybody stop. I have seen way too many times Kids try to plug in for B, A, and C. They miss a negative sign here, a positive sign here, and it comes out to be totally incorrect. One way you can never, ever get this incorrect is by using your calculator. You probably don't remember Unit 1. I introduced this store key to you. All right. What we're going to do right now is we're going to store in A, B, and C values into the calculator. What was my A value? 2. So I'm going to tell the calculator, everyone ready? 2, store button right here above the on button. Store it in for what variable? A, which is right above the math. So alpha math. Store it in for A. Enter. What about my B? What's my B value? -1. Store that in for B, right above the apps button. And then what's my C value? C value? -15. Store in for C. Trouble locating these buttons here. And now what do I want to know the value of? Ready? B squared minus 4AC. Your calculator's not going to make a mistake. And that tells you the value underneath the radical, the discriminant, is 121. Can't get it wrong. Nope, because I'm hoping you plug it in your calculator. Now, how do I use that number to see if it's factorable or not? If that discriminant is a perfect square, you could factor. If it's not a perfect square, you can't factor it. 121, perfect square? I don't know. Some of you are like, heck, I have no idea. How can I check real quick if it's a perfect square? Go back to your calculator, see if you can actually take the square root of 121. And look what happens. Can you? Yes, I can. So because 121 is a perfect square, this is factorable. I'm not asking you to factor it. I just want to know, could you factor it or not? And the answer is darn right you can. All right, try out the next one now by storing on your calculator. What's your A value on the next one here? A value of 3, B value? -19, and a C value? 10. Go right ahead. Let's see if we can all come up with the same discriminant value. You shouldn't. What do you mean round? There shouldn't be any rounding here. You're not taking the square root. You're just doing B squared minus 4AC. The discriminant is that part, not the radical part. Okay, sorry, not my problem, Teddy. Okay. Can we get a common number right now underneath the radical? 241. I have no idea if that's a perfect square or not, but I can certainly just quickly go to the calculator and say, hey, what is the square root of 241? And I figure out real quickly that it's not a perfect square. So even if I wanted to, you could not factor that trinomial. So then what, if I can't factor it, then how the heck do I still solve it? And this is where I now introduce the quadratic formula. All right. Good news for some of you guys that prefer not to factor. Quadratic formula can be used for anything. All right, even if you can factor it or not, you are always allowed to use quadratic formula. Now, is it a lot longer than just Finding two numbers that multiply to C and add to B, yeah, it is. And being an honors level class, I would try to hope you would try to factor it, but I can't stop you from not using quadratic formula. All right, so let's use quadratic formula right here on number 3. A value, 1, B value, 2, C value, -1. All right, so let's get out the quadratic formula, which I will give you on a reference sheet next Monday for the quiz. B squared minus 4AC all over 2A. All right. What was my B value? 2. So when I plug it in right now, this first part, it'll become -2. What was my A value? A value? 1. So when you plug it in the denominator, it'll be 2. And you know what? I'm not doing a darn thing underneath that radical. I'm not substituting in anything. I'm going to go where? Where am I going to find that number out? Right on the store key in the calculator. I'm not plugging in a darn thing into B squared minus 4AC. I'm going to let the calculator do all the work. Because I am too nervous, I'm going to get a sign wrong somewhere. So I'm going to store in 1, 2, and -1, and then let the calculator tell me what B squared minus 4AC is equal to. Can we get a agreement? What's underneath that radical? 8? Perfect. I got an 8 underneath that radical. Everyone getting an 8. Okay. We're not done though. This is why we practice it. What am I going to have you do with that square root of 8? Simplify it. All right, you are not done here. We can still break down square root of 8. So go ahead. -2 plus or minus. Still got the 2 in the denominator. I need you to simplify the square root of 8 for me. And what's that simplify to? All the way, please, all the way. Here we go, number 10. What's that simplify to? -2? There you go. Everyone good? That's what 8 breaks down into. 2 radical 2. You think you can keep going? Any reducing I could still do? Any reducing? Yeah. All right. Hey, even the best here. Focus in. See how I'm dividing this by +2? That applies to the left side of the plus or minus and to the right side. All right, ready? Watch. -2 over 2. -1. The 2 is still there. All right, just not on that side. Everyone see how I got -1? Plus or minus. Now, go to the other side. Can I reduce here? What reduces? Not the radical 2, but these 2's right here. So it'll be -1 plus or minus radical 2. Everyone see that? Just because you cross it out here doesn't mean it's gone. It applies to the left side and the right side of the plus or minus. Questions? 1 doesn't make you great. That's for darn sure. 4. What's the problem with 4 before I even touch it? It's got to be equal to 0. Just before you it's got to be equal to 0. So you can move the 5x over. How? Subtract it over. So 3x squared. And probably prefer what here? Write it in the correct order. Don't leave it -1 minus 5x because you probably get the BC value wrong. So minus 5x minus 1. What's your A value? 3. B value. And C value. All right, here we go. Let's get it using the quadratic formula. When you plug in that -5 for negative b, it'll become what? 5 plus or minus. I don't care what's underneath. The calculator will tell me. What's in the denominator now? 2 times 3, which would be 6. Let's see what number you get underneath the radical. Store away. What do you guys get underneath the radical? 30? Okay, perfect. This one's going to be a little different than the previous one. Here's why. Anybody find a perfect square that goes into 37 so I can start breaking this down? Anybody find one? Me neither. So if I can't find anything that goes into the radical, I can't break it down, we're done. I don't have to do all the work I did up above because I didn't simplify the radical. All right. That's it. Hey, even let's say instead of a 5 there, let's say there's a 12 there. And you're thinking, oh, 12 divided by 6, I'm going to put, let's see, a 2 here. Nope, 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 nope. Leave it. If you cannot simplify the radical, you're done. All right, leave it. Questions? All right, I'm going to save example 5 until tomorrow so you can flip it over and start your at least a couple problems, get a couple until the bell rings. All right, 5 we'll do first thing tomorrow as a review.